Okay, in the last section of this video, we looked at the equation for finding the slope of a line. So let's recall that that is m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So at this point, I want to kind of take a look at how do we deal with our two special cases of lines. So when we talk about our two special cases, you might recall what those are from the last one, but let me start with an example. Suppose I ask you to find the slope of the points of the line through the points, but find the slope given the points 3, 4 and 7, 4. Okay. Now if I were to look at this on a graph, you might notice that that the points 3, 4 and 7, 4 line up right across from each other, so the type of line we get is a horizontal line. Alright, so what happens to the slope here? Well, let's apply our slope formula. M is equal to, now what are our x and y values? Now again, if it's helpful, come in here and put your x sub 1, y sub 1, x sub 2, y sub 2 over your points so you can keep them straight. So I'm going to have my y's, which is 4 minus 4, over 7 minus 3. And I end up with 0 over 4, which equals, well, if I have 0/4 of anything, I don't have any parts, so that actually is 0. So when I'm looking at a horizontal line, you need to remember that horizontal lines have a slope of 0. And that will always be true. If you know 2 points, you can calculate it, but if you just see a horizontal line anywhere, you know that it has a slope of 0. Let's look at another example. Suppose I ask you to find the slope given the points 2, 1 and 2, 5. So again, we could come in here and say this is x sub 1, y sub 1, x sub 2, y sub 2. And if we looked at the graph of this particular one, let's see, 1, 2, 3, 1, 2, 3, 4, 5. Again, 2, 1 would be right about there, and 2, 5 would be way up here. And you'll notice that those 2 points actually lie on a, whoops, you can't see the graph, sorry about that, on the vertical line. So if I look to find the slope here, my slope is m is equal to, now my y sub 2 is 5, my y sub 1 is 1, over 2 minus 2. Well, that gives me a 4 over 0. It's upside down from up here, and what does that mean? Well, by definition, we cannot divide by 0, so when we're talking about slopes, this is an undefined value. And so therefore, when we're talking about vertical lines have a slope that is undefined. And so you want to keep that in mind with vertical lines. Okay, horizontal have a 0, vertical have an undefined slope. Now, a couple of other things that I want to take a look at today. The first one is the idea of parallel lines. When we're dealing with parallel lines, there are some unique characteristics of parallel lines that are associated with slopes. So let's say that I take a look at a graph of two parallel lines. And let's say that they're going to look something like this. Think of train tracks. They're side by side here. So what is something that you can tell me about the slopes of those two lines? Well, they seem to be having the same steepness to them. If I were to use some stair steps here, depending on where I am, those actually seem to be the same. So we can basically say that two non-vertical lines with the same slope and different y-intercepts are parallel. Okay, so you'll notice this one has a y-intercept up here, this one has a y-intercept down here. Those are different y-intercepts, but they do seem to have the same slope, and so when they have the same slope, we say they're parallel. Now the symbol we typically use mathematically for this is two little parallel lines. So if I were to say this is line 1 and this is line 2, or L sub 1 and L sub 2, I could say L sub 1 is parallel to L sub 2. That would be the symbolism we would use. Another thing to remember is, even though that we say that we're looking at non-vertical lines here, and part of the reason for that is because, remember, a vertical line has an undefined slope, so we can't really talk about slopes when we're talking about parallel lines and vertical lines. We do also say that any two vertical lines are parallel. Okay, so parallel lines have the same slope. Now another one that we want to take a look at is a little bit different than this one, and this one's going to be a little bit trickier to actually fully comprehend. So we're going to take a look here at a graph of this next situation. So let's say that I plot a couple of lines here. So let's say I create a line that has the point -1, -2, and 0, 3 on it. And so let's say that we have this particular line right here. And now let's take the point 0, 2 and 5, 1, and let's sketch this line right here. Again, not exactly perfectly straight, but if you take a look at those lines, what relationship do you seem to see there? Well, these two lines have a very unique relationship. They are what we refer to as perpendicular lines. Now, when we talk about something being perpendicular, especially with lines being perpendicular to each other, it means they meet at a right angle. And so if you look at here, it looks like we have a right angle that's formed right there where those two lines actually intersect. Now let's see if we can take a look at the slopes of these two lines and see what kind of a relationship there is. So if I look at, again, the points that I used here for line number 1, the points I plotted were -1, -2, and 0, 3. Let's take a look at the slope. M is equal to, and again, if it's helpful, write in your x sub 1, y sub 1, x sub 2, y sub 2. And we have 3 minus a -2 divided by 0 minus a negative 1. So if we're careful in computing this, 3 minus a negative 2 becomes 3 plus 2. A 0 minus a negative 1 becomes 0 plus 1. So this becomes a 5 over 1. Or, simply stated, it would be a 5. Let's look at the second line. The second line had the points 0, 2 and 5, 1. So again, if we look at our x sub 1, y sub 1, and x sub 2, y sub 2, we end up with m equaling 1 minus 2 divided by 5 minus 0. And this gives us a negative 1 over 5. Interesting. Well, let's see. How are these two related? And I'm going to look at both of them in fraction form because it gives me a little bit more information. Notice that these are actually what we mathematically say are reciprocals of each other. But not only are they reciprocals, but notice one is positive and one is negative. So we can say that they are negative reciprocals of each other. And that would be the simple way of talking about that. Now in general, if I take a look at the slopes of these two lines, so remember I used slope in both of these cases. Since this was a slope for line 1, I might call it m sub 1. Since this was a slope for line 2, I might call this m2. So I can say that m sub 1 times m sub 2, or when I multiply these two slopes, they end up giving me a result of negative 1. And this is a little fact that's always going to be true when you're dealing with perpendicular lines. So look at this example. 5 over 1 times negative 1 over 5 is negative 5 over 5, which is negative 1. So what we can say about perpendicular lines is, again, their slopes are negative reciprocals of each other. So if we want to write that in a statement, we can say two lines whose slopes are negative reciprocals of each other are perpendicular. Now we also have a special case with the perpendicular lines, much like we had with the parallel lines. We can say that any vertical line, remember vertical lines have an undefined slope, any vertical line is perpendicular to a horizontal line. Now, as with parallel lines, when we are talking about a symbol for perpendicular, we use the symbol kind of an upside down T to represent perpendicular because it kind of indicates that right angle I talked about earlier. So if I look at the previous two lines, I could say that line 1 is perpendicular to line 2, and that would be the shorthand way of being able to write that. So I hope this gives you some additional information to be able to look at section 7.3. Please see the website for the assignment.